Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Faeez Haikhal bin Muhammad Fuad, and I will be presenting to you about the lab torsion test. So, objective of this lab is to determine the modulus of rigidity, maximum shearing stress, maximum shearing strain, and the pressure ratio for the test specimen. Second objective, to study the linearly elastic behavior of the tested specimen under torsion and to obtain the relationship between torsional load and angle of the twist for a full range of strain until failure. So, for the procedure, first measure the diameter and the length of the test specimen. Draw a straight line using the pencil lead on the specimen length in order to observe the effect of twisting. Fix the both end of the specimen into the specimen holder. Mount the specimen between the loading device and the torture measuring unit. Make sure that the shifting specimen holder of the load is in the mid position. Make sure that the specimen is not initially loaded. Turn on the hand wheel clockwise to provide the apply load. Switch on the measurement amplifier and set it to the zero. The read up value is apply torture. And for the first rotation, choose an increment of the quarter rotation 990 degree. For the second rotation 900. For the third rotation, of the quarter rotation is 90 degree. It's 90 degree. For the second and the third rotation of a half rotation is 180 degree, and the fourth to 8 rotation of one rotation is 360 degree. For the 9 two specimen fracture, take the reading of the applied load and angle of the twist for each 5 or 10 rotation. So this is the result for the steel. Result for the brass. So let's go into the discussion. For the first question, compare the result of the test between the experiment and reference value of the modulus of rigidity, pressure ratio, shear stress, and shear strain. Comment on any differences and a possible source of error. Because of systematic fault in the machine inaccuracy and sensitivity, the experimental value of the modulus of rigidity, pressure ratio, shear stress, and shear strain differ from the reference value given in the appendix. The second question. Describe the behavior of this material as it responds to increasing applied torture. When the increasing force is applied to the brass, before it reaches its fracture, it will fracture brittly, but still will fracture deductively as it approaches failure. Third question. Is the Hooke's law for the shearing stress and the strain valid? And explain. Only if the shear stress is directly proportional to the shear strain is the Hooke law applicable. To such limitation, when the Hooke rule reached a proportionate limit, it was no longer true and invalid. Third question. Describe the appearance of the fracture surface of the test specimen and discuss the mode of the failure, ductile failure or brittle failure under torsion. The steel fracture surface has a ductile look. The ductile fracture surface resembles a cup and cone once it has been shattered. The ductile surface is weakened by significant plastic deformation before its crack. The brass fracture surface has a brittle look as the fracture propagates through the material via cleavage, perpendicular to the direction of the applied stress. The brittle fracture surface is relatively smoothly. And the fifth question is, which should be able resist more torture, solid bar or hollow bar of the same material and the cross-sectional area, and explain. A hollow bar is better than a solid when it comes to the torture resistance, because a hollow bar has a lower polar moment of the inertia than a solid bar. This is the case. The bar ability to twist is hampered as the result of this. So for the conclusion, we can calculate the modulus of rigidity, maximum shear stress, maximum shear strain, and the pressure ratio for the steel and the brass using this experiment. In all standard, they have different meanings. We can deduce the brass is the brittle and the steel is the ductile. Under torsion, the linear elastic behavior of the steel and the brass can also be observed. Aside from that, we can deduce that the relationship between torsional load and the twist angle is linear. In addition, the steel and the bar shear modular were successfully obtained. So that's all from me, and thank you.